Hi, good afternoon, everyone. It's now 4:30, so we're going to go ahead and get started with our final session of the day, which is session 5, FAS Overview. So today we have 3 session speakers. Actually, before we get started, I completely forgot. Just some quick administrative announcements. If you are just joining us, or missed the beginning of the sessions previously, please remember to stay on mute. That way it minimizes interruptions and distractions. And then if you do have any questions, please put all of them in our Zoom chat. That way they can be answered at the end of our session, during our Q&A portion. So our session speakers today are Bhavani, Ava, and Nikhil, and I'm going to be turning things over to them to give you more information about themselves and then their session today.
Thank you, Julia. Hello, everyone. I'm Bhavani Murari, Project Manager of the AIM project. I have Ava Bakri, who's our business analyst, and Nikhil Nirale, who's our Chief Data Scientist here. We have the last session of the day, and we're going to be doing an overview of the FAS system. And also, if time permits, we also want to do a short demo to show what are the features of FAS. So I'm going to go ahead and Julia, if you want to, and I'll let our speakers introduce while we get there, or you want us to go through the introduction?
It's really whatever you prefer. I can certainly pause on this slide if that would be easier now
Yeah,
to
I
get.
think that would be easier. Ava.
Okay, yeah, that sounds great.
Ava, you want to introduce yourself before we move on?
Oh, yeah. Hi, everyone. My name is Ava Badji. I am the business analyst on the AIM project. I've been working with what we're going to demo, the FAS system, for a little over a year, maybe 2 years now, and as well as some of the newer developments we've been working on additionally on AIM with the 2567 data, which would be in the dashboard that we demo if there's time. Yeah, thanks, Bhavani.
Great, Nikhil.
Yeah, thanks, Vani. Hello, everyone, and good afternoon. I think Eva and Bhavani have already summarized what we do as part of FAS and 2567, CASA in short. So I won't take up much time. Looking forward to the discussion here. Thank you.
Thank you, Nikhil. And Julia, due to the time, and we have like half an hour, and we also want to give like 5 minutes for the question. So I'm going to just go ahead and finish up the presentation myself and then turn it over to Ava, and Nikhil would be available for any questions or anything that I want to turn it over to him.
Okay, that sounds good. Were you asking so I could give you time checks, or you want to just roll through?
I think I'll manage. Yeah.
Sounds good.
Okay, so thanks everyone. So we are here to, as you said, we're going to do an introduction to AIM. We have a short video that kind of explains what is FAS, what is it we're going to do, and then we're going to do a high-level demo of FAS user interface and the 2567 NH survey dashboard. So let's move on to the next slide that gives a quick introduction of FAS. It's a video.
Machine learning and artificial intelligence are transforming the workplace. CMS and CCSQ are utilizing an AI solution, artificial intelligence through machine learned modeling, AIM, which uses natural language processing, NLP, and machine learning, ML, to assist with labor-intensive, daunting tasks. When the government proposes changes to a rule, stakeholders submit comments on regulations.gov. Logistically, this is a challenge to process. The volume of comments, difficulty in categorizing and organizing them, and the struggle to understand and quantify the overall sentiment from commenters can be overwhelming. There are often tight timelines to read, analyze, and respond to comments. and comments aren't always in the same format. The responses to these comments are crucial, as the impact on programs and policies can be significant. Yes, comment review is manually intensive and time-consuming, but it doesn't have to be. By applying ML and NLP, the branch of AI that allows computers to understand and interpret human language, we can alleviate much of the burden. Enter the Feedback Analysis System, FAS. This solution works through that text data and analyzes comments, deploying various models that detect duplicate comments and those with similar text and group them together. It groups by topic. It identifies the submitter of the comment and the type of stakeholder that submitted the comment. It detects and groups comment themes, and it detects sentiments within the comments, all viewable within an interactive interface. Let's demonstrate that last one. FAS detects and highlights dark statements, disagreement, agreement, recommendation, and clarification statements a commenter made regarding policy. Here, the disagreement and agreement model, a deep learning text classification model, analyzes comment text and automatically identifies sentiment statements that are in agreement or disagreement with the proposed rule content. When it finds an instance, an annotation is made. This lightens the workload for the user, as they can see the annotations and change them if necessary. CMS collected responses from a nursing home survey form, 2567, and needed support ingesting, analyzing, and visualizing the data. ML and NLP simplify this task by identifying elements like facts, findings, evidence, dates and time, and other components documented within a survey. The solution identifies the potentially undercited and overcited surveys, and it uses ML to identify and flag for further review surveys with language that suggests a higher severity than what was cited. Interactive data visualization dashboards provide various data points on survey form 2567 analysis, such as survey results by state, deficiency levels, and distribution by state, as well as other model insights.
Great, thanks for that, Julia. And so moving on to the content of this presentation, I think the video kind of gives a lot of information and introduction on what FAS is and what is that we do. So I'm going to run through these slides a little quickly so that we have time to do some demo. So as we saw in the video, FAS is the first use case that we developed for CSG, OC, and CAG groups to assist in the analysis of public comments. You all saw in the video how it looks at the comments, looks at the sentiments, have this annotation feature. So all that is provided as part of the FAS application. That is the first use case. The second use case, what we have is the nursing home system, nursing home survey analysis system, which is to ingest the 2567s and analyze the data using machine learning and NLP, and being able to identify undercited and oversighted, as we saw in the video. We do have a new user interface in the works that is going to have, it's called CASA. It's going to have a user interface for users to look at the nursing home surveys and a little bit more functionalities than just a dashboard. But we don't have that yet. It's something in the works. Next slide, Julia. And here this slide shows a little, an overall picture of how FAS works. So if you can see from left to right, the FAS is, there is intensive manual labor to sort and categorize, analyze the comments. FAS ingests these information, all these public comments that comes from regulations.gov through, we have set up APIs. To consume the APIs that regulations.gov exposes, and then it ingests the comments. Once the comments are ingested, it goes through the models, and the model results are posted in the UI. And analysts can come in, and then they can review the comment. They can look at the sentiments. They can annotate. They can categorize, filter the comments, and once everything is done, then they'll be able to publish the final proposal on the regulations.gov. So this kind of takes away all the manual labor, that would be involved if they don't have a way to do this in a more systematic manner. Next slide, Julia. These are some of the features. Due to the time, I don't want to go through each and every one of them, but this is something similar to what we saw in the video, where there is a duplicate comment detection. We have a way to identify the submitter, identify the stakeholder, automatic detection, which is the sentiments that we talked about. It identifies disagreement, agreement, recommendation, and clarification, and it also identifies themes and allows the user to categorize and group by the themes. Next slide. These are the models that we have developed for FAS use case. So, there are various models that does a specific functionality that contributes to the overall solution. The themes model, which identifies the recurring ideas within the proposed rule comments, generate coherent representations. Again, all these you would see all these things allowing users to categorize and to filter based on these categories. So stakeholder and the stakeholder type, it will allow user to identify by the stakeholder. If they are interested in only looking at a particular stakeholder comments, then it allows them to do so. Disagreement, agreement, where the user's sentiments are being analyzed, and then people are able to see just the agreements or just the disagreements to be able to make an informed decision. Duplicate detection that we talked about, and also the other one is for identify the topics. So this is a framework that would, it will map the proposed comment sections to be able to get to a topic, and then the topics do get identified ahead of time, and it'll allow them to map the comment to a topic, which is a great feature for users, analysts looking at these comments to be able to categorize the comments by the topic, so they make a better informed decision. Moving on to the next slide. The next one, we are talking about use case 2, where we are CMS 2567 nursing home surveys. So these are the forms 2567. That's a CMS form, which is used by surveyors to include deficiencies about the nursing home surveys that they conduct, and they have certain rules in how they do the survey and how they fill up this form. The idea for this work is to be able for FAS to have a way to ingest all the surveys, the 2567 forms, and be able to employ the NLP and ML techniques to identify if the surveys are undercited or oversighted. So that's what we do. And the results are in the dashboard currently. And this is what I talked about, that we do have a UI coming up soon. We don't have that yet, but there is a dashboard that displays all this information where users can go in and they can look at from a state point of view, which state has how many surveys. They do have the option to go look at the actual survey from the dashboard also. Next slide, please. So some of the pain points that we have as part of the nursing home survey, the states are responsible for following the CMS guidance to perform nursing home surveys. The volume is huge, and the text data makes it impossible to review every single deficiency. SOD is statement of deficiency. And there are 500K deficiency included on Care Compare. Each of them will have, each survey would have each of these can have many pages of the statement of deficiencies that is included. So it's manually kind of not possible to look at each and every one of them. And the timely review of the survey is very important. And CMS has policy in place to be able to follow CMS guidance for citing deficiencies and appropriate scope and severity level. Next slide. Features developed for the 2567 use case, or we have a model in place, which is the severity model, and we are actually in the process of developing a scope model, which identifies the scope, of the survey, like, is it like one person, or, what is this, how many people is it impacting? So that kind of analysis is also going on currently. We have, the flag for severity identification. That is a framework which identifies the potentially undercited and oversighted nursing home surveys. The user access is integrated with FAS. As I said, the work underway to stand this up as a separate application is in progress. But currently, the user access is, if it's a FAS user, there is a way for them to go into the 2567 dashboard and look at the data from there. Data ingestion is from the public sites. These are all public data. And the data processing is automated extraction of the survey ID, the addition of the severity level, the regulatory groups. And we also have the entity identification, which is to automatically identify critical elements in the 2567 deficiency text, such as survey action, extent, fact-finding evidence, sample, universe. And we actually expanded the identification of the critical elements in the new UI that we are building. But this is what, the dashboards that have some of this information in there. And as I said before, the dashboard, it visualizes the various survey statistics nationally and by state. And all the models, like even with CASA, with the 2567 or with FAS, the model processing and stuff, it includes us training the models and in multiple iterations and making sure, experimenting on the approaches, training the models, and also having model results or the predictions being validated, not only internally, but also involving CMS. So we go through a thorough process of the model result validation before the model results are getting published. Next slide, please. Other supported features that we have, or we are in the process of getting a, looking at, we are in the process of going through TDD for a usage of LLMs for several other use cases. Several other use cases we have in place, and we also have an audio file ingestion POC that we worked on, which was a successful POC. And we're also looking at getting the analysis of policy proposal feedback from multiple data sources. So we are always welcoming new use cases because we do have a framework built, and it's in any new use cases that requires this kind of an ML and NLP solution, then the framework is there, which we'll be able to accommodate new use cases. Next slide, please. Is it the last slide, Julia?
Hang on one second, because I'm in speaker view. Let me double check. Yeah, so the one after this is the demo.
Demo. Okay, I'm going to turn it over to, I know we have 10 minutes, I'm going to turn it over to Ava for a quick demo so you all can see the UI.
Awesome, thanks, Bhavani. I'm gonna request to share.
Yeah.
Right, I'm sharing my screen. You should see a web browser with feedback analysis system in the top left-hand corner.
Yep, Ava looks good.
Great, thank you guys for confirming. All right, so this is the interface for the FAS system. As mentioned, we've been working with a few different groups in CMS, CSG, OCE, and CAG. And over time, we've loaded in a few different dockets, so I can kind of scroll down here on our page just so you can see kind of dating back to as early as 2020. Some dockets get lots of comments, some are very minimal, some are like 10,000, some go close to 20. I think the most comments we've seen is like 46,000. So it can get pretty hectic for the analysts. So as part of the demo, I'm just going to go into this most recent document that we've been working on. Going into here, you see that we have a remove duplicate comments filter active. So that's kind of automatically selected. That just allows this list that populates here in this table to be unique or only unique comments, basically giving the users a view of non-duplicative content. I can see that there's a few topic filters, so I can organize my comments by topics, by categories, by location, by the type of stakeholder, if that information has been found or has been submitted, the setting of care, if that's applicable, the specialty, sometimes certain, types of providers will have comments sent in by, like cardiologists or neurologists. And so that information, if it's included, will be picked up, as well as role. So, if you're a doctor, what's your specialty, or if you're a medical director, that information, again, if it's listed in the comment, will get picked up. Lastly, we have our recommendation and clarification filters and our sentiment for agreement and disagreement. And then the themes, where we can kind of start to see what themes occur in the comments and see what group, how those comments are organized by these thematic groups. Just to kind of apply these filters I have selected and go into a comment, I am going to sort these. So here I can see, I've added some filters. I can see the information that's been found by the model, if it's been found. Sometimes the type of stakeholder isn't available, and I can kind of go into what that looks like here. So this is a comment from what looks like a skin service, a laser provider, and I can see that the submitter org is Strata, so I'm going to confirm that. The type, the stakeholder type is industry. Since this is somebody from an industry, I can, confirm that the setting of care doesn't exist here. This does seem to be dermatology, so, and I'll show you that in the comment. I can create that specialty when it doesn't exist in the list already, and I can see that probably this is in the comment. See if it's a physician commenting or if it's just a representative. So here is Strata Skin Services. They they create lasers for dermatologists. Let's see what their signed comment is. Sometimes they have it. Executive officer. So I can say that this is wrong. It's not a physician. So that's kind of quickly how I can provide feedback on some of those modeling outputs. And like I'm able to see that information after I've provided that. And going into this document, this view of the comment this company has submitted, but I can click show text and modeling data, and I'm able to see kind of some of those annotations that were mentioned in the video. Looks like there's a good bit of recommendations here. They get highlighted in the text, and I can scroll down and see some more of these. So those are kind of pulled out for the analysts to see quickly. Also, I can flag this comment and say, okay, maybe I want to come back to it, or maybe I want to add another recommendation that I see in the text. And so I'll go in and I'll highlight that and see that that gets added as well here at the top. So I can kind of customize what I see here. Maybe I see one that I don't really agree with, so I'll remove it. And I see that also gets removed from the highlights. And then looking across the other attached files that this commenter submitted, a lot of times they'll submit supporting material. And so this appears to be kind of some data that backs up some of the probably recommendations in their comments. So it appears that all, yep, another supporting data. And yeah, more supporting documents. So it looks like this first one was only the comment, the subject of the comment was in this first attachment. So after I've reviewed that, I can click review, and then I can go and see all the comments that I've either reviewed or flagged as part of this docket. So I just reviewed that strata comment. So I see that here, and I can download this list externally, bring it out, do kind of any kind of further analysis if I need to. I can also see the ones I flagged and similarly download that list of comments. I'm able to go in and see the similar groups that are found. As I mentioned, we have a deduplication process, so we have a similarity dashboard that we provide kind of some insights, so I can kind of see, you know, of the 6,900 comments, there's about 175 groups found. It looks like group 151 has a good bit of comments, so I'll go into that one and see. Here, I know the dashboard, their text is kind of small. Kind of start to zoom in a little bit, but you can kind of start to see that the text for these are all the same. So they're just found under one group, and then one representative copy is kept in the comment list for reviewers to look over. I can also go to my stakeholder dashboard and start to see and filter on different stakeholder types. So maybe I just want to see the industry commenters, so I can kind of come and see that view here pretty easily as well, and just get it. I can also export this to Excel just if I wanted to see, okay, what industries are commenting on this proposal. So you're able to kind of gain some quick insights from our dashboards. We also have a summary view dashboard that kind of just gives a little bit of more broad data. The comments posted by the date, so you can kind of start to see when comments were more heavily posted on the regs.gov site. You can see by the category or by topic, as well as that breakdown by state. And then lastly, I think I have, yes, so the annotations. I mentioned you can add annotations to comments, or you can save them. So if I wanted to see all the recommendations that I saved, the comment 4503 that I was just on, I see all of the recommendations that were found under that one, and I can download this list as well and kind of bring it, you know, to Excel or wherever if I've got some additional external analysis I want to get done. That kind of concludes our brief overview, and I know we are at 5 o'clock almost, so I can show the dashboard or I can just pass it back to you, Julia.
Totally up to you, Ava. I don't know if that would be brief and you would have time to do that.
It can be brief. I can be whatever we need. So quickly going into our dashboard that was mentioned as the second use case for the AIM project. So we kind of have some general metrics here. We've got just basic numbers, the number of facilities, the number of surveys, the number of surveyors. Deficiencies are the citations that kind of make up a survey. So there's multiple deficiencies in a survey, and they vary by type. So those types you'll see here: standard, complaint, and infection control. So you see those number breakdowns. This makes more sense to the analysts who are looking at this data. often, but just as an overview. One of our models that we've developed for this use case is that flagging for over or under citation, essentially just flagging deficiencies that have text that may suggest there's something more going on here than what was cited. So we can see some quick metrics based on, no filters. Let's see if I wanted to just see the last year. I could see about 4.82% of deficiencies are being flagged for severity, and I can kind of start to look and see which states are maybe hotspots or maybe have higher percentages there. And again, these are saying that these are flagged, so they require additional review. They're not 100% saying these are under or oversighted. They're just saying the text is maybe not aligning with the citation that was documented. Under here, we also can see some other metrics based on the deficiencies that get cited. Deficiencies are grouped under different categories, and they're called F tags. So we can kind of see which tags are being cited often. This kind of goes into like quality of care, certain instances of abuse or neglect. So it's all organized, but this kind of provides a way for analysts to see which tags are most often being cited and what regulatory group, larger group they belong under. Similarly, we kind of can see a breakdown of the tags or the regulatory groups that have citations and what percent of those are flagged by the system. So you can kind of see, maybe there's opportunity for improvement on guidance under quality of care, or maybe the training needs help, or maybe they're just not writing the surveys right, and we just need to get in there and teach them how to do that. So that's maybe some possible insights you can gain there. We have a little bit more of an in-depth look at the deficiency data here in this tab, where we can kind of get to a tabular view. So if I wanted to see, the quality of care deficiencies in the regulatory group for this past year, maybe I want to see it for the Atlanta region. I can see this information. Give it 1 second. There is a lot of data on here that's being loaded, so it does take just a minute. So I can kind of see that, and then as Bhavani mentioned, you can go and click on these links and be brought to that survey with the deficiency. Here we can see, ones in this table, whether or not they were flagged for severity. So this deficiency is cited at F684, and it was flagged and predicted to be a level 4, so that's a little serious, but analysts can kind of come in here and see this information and go to these surveys as they need to. We can also see kind of the deficiencies over time, which deficiencies are being cited more often when. That's always kind of useful. And then lastly, we have our facility tab, where you can, at a facility level, kind of go deeply into these deficiency citations. So you can see maybe, let me see if can do flagged for severity. Yes, maybe I just want to see what's been flagged and see what the predicted ones are. So maybe I can start to triage, like, okay, I want to really focus on things that are predicted at a level 4 rather than a level 3, even though they're both pretty serious. So that's kind of a really quick, brief overview, not getting into too much and not taking more than 5 minutes of everyone's additional time. So thank you guys. I'm going to stop sharing and hand it back to you, Julia.
Thanks so much, Ava.
Mm-hmm.
Okay. Oh, my duck. Okay. Really, I just want to go over this final slide. Because I know we are over time, but just going into tomorrow. So thank you so much to the AIM team. I appreciate your time. So moving into tomorrow, we are going to kick things off with CDR Medicare claims. And then next we're going to SAS to Python conversion, introduction to SAS to PyTool, then introduction to data, best practices. And then our final session is going to be object-oriented programming 101. And then we'll have some quick closing remarks from Kent Howard to kind of round us out for tomorrow evening. So with that, thank you to everyone who attended today and to all our many presenters. It was a great first day to kick things off. So we look forward to seeing you back here tomorrow starting at 1 p.m. Eastern time. Thank you so much. Have a great night.
Thanks all.